Hi, everyone. Well, the applications that we build today, they have these properties that we need to fulfill. They need to scale quickly to be able to manage potentially millions of users. We need to have global availability. We need to manage large amounts of data. And it should, of course, respond in milliseconds. And all of this while we maintain developer agility. So we're able to release new features fast. And we should keep our applications safe. And the application should, of course, be both reliable and resilient to failure. So that's a quite tough equation for us. My name is Gunnar Grosch. I am a senior developer advocate at AWS. And today I want to talk about how we can verify that our serverless applications behave as we expect them to. And I'm going to do that by showing what verification is, how to do it, and several practical examples of verification for serverless applications. So this is a statement from the reliability pillar of the AWS well-architected framework. Testing to ensure that you can meet your availability goals is the only way you can have confidence that you will meet those goals. And what this tells me is that even though we follow best practices, for instance, by using the well-architected framework, we use services that are built for high availability and so on. Building modern applications that are often distributed by default, it is complex. So we can't really gain that confidence in our system until we've seen it face adverse conditions. So we have all of this complexity in our applications. So how do we keep moving fast and not break things? We as an industry, we're usually good at reactive measures. For instance, incident response, disaster recovery, and different testing methods like unit tests and integration tests. But verification, that is a proactive experimentation for verifying the system behavior. So verification tells us why it's important to explore a set of conditions and the impact on something that we care about. So let me show you. Well, when we do verification, we follow this process. And the first thing is that we need to have an objective. And the objective for verification, that's something that we care about, something that shows that our system is available. So it can be page loads, clicks per second, processing speed, and so on. Something that we care about. And the objective, of course, needs to be measurable. So when we've defined the objective, for instance, as a business level, I want 10 items added in cart per second. Well, then we can track the number of items added in cart per second. Or if it's a technical objective, I want my purchase API to respond in less than 400 milliseconds. Well, then we're able to measure the purchase API and set a threshold for that. And when we have the objective and we've made sure that it's measurables and we have our thresholds, then we add different conditions to the verification. And the conditions, well, they reflect different events that could occur within our system. So what if there is additional latency to each API call? Will the API still respond in less than 400 milliseconds? Or what if there is a downstream service error? Will we still get these 10 items added in cart per second? So with the objective, the measures, and one or several conditions in place, we can then verify our system's behavior. So that's the process that we're following for verifying our system. So if we look at this from a site reliability engineering or SRE standpoint, that might mean that the objectives are our SLOs and the measures are our SLIs. And the conditions, well, they are different kind of events that might occur and might affect our system. So let's look a bit closer at conditions then. As I said, conditions, they reflect different events that could occur in the system. So this is where chaos engineering comes into verification. And we can now add our chaos engineering experiments as a condition to our system verification. And chaos engineering, well, that is a matter of learning by injecting failure into our system. So that's what we're doing with the conditions. So when we're working with verification, we add those conditions and we do it as a way to learn how the system behaves when there is failure, when there are adverse conditions. So it's really not about breaking the system. It's about learning and building confidence in the system. So let me show you a few examples of conditions that we can add to our system. So we have this simple web service, serverless web service. It consists of an API gateway, and behind that we have two Lambda functions being invoked when the client calls the API. One of the Lambda functions retrieves or stores data in S3, object storage, and the other one retrieves or stores data in a DynamoDB table. And we also have an S3 bucket for, say, static content. So simple web service. So we can then think about different conditions that could exist in this kind of application. And we can then add those as conditions in our verification. So for instance, what if there are errors in our code? If our Lambda function invocation throws an error, what happens to the application in those cases? What if we have different security policy errors or service configuration errors? Those are errors that we perhaps might add to our application, not on purpose perhaps, but through different deployments or changes in our application. And these are conditions that we can add then. Or if we're using the disk space within our Lambda functions, what happens if we aren't able to store items in the temp space of our Lambda function? Perhaps we're using that to manipulate data, or if we're using it for caching purposes, for instance. And one very common, of course, is different kind of downstream service issues. In this case, the architecture had other AWS services as downstream services, but very common is to use third-party services as well, services that we might call through APIs, for instance. And we can, of course, also affect the concurrency of functions and throttling for different services. And we can add latency. That's a very common one. So add latency to our function invocations to test different failure scenarios. For instance, see what happens if each Lambda invocation has an added latency that affects the way that we return data, for instance, back to our API gateway. So these are different conditions that we can use. There are, of course, many other examples as well, but these are very common ones that I tend to use when doing these kind of experiments. And to do this for serverless, some of them, we can simply do them by changing configuration through CLI or through console, for instance. Others, we need to be a bit more creative when doing. So there are two specific tools that we can use. One is called coalesce. It is a Python package that we can use for our Python-based Lambda functions. And the other is called Failure-lambda for our Node.js-based Lambda functions. And by using these two tools, we're then able to add different failure scenarios as conditions in our verification process. So tools created to do chaos experiments. So I want to show you how Failure-lambda works. It is an NPM package for our Node.js Lambdas, so we can simply install it as an NPM package. And the configuration for this is something that we store as a parameter, either in Systems Manager parameter store or using AWS AppConfig. AppConfig is a service that's great for storing configuration and have that separate from our code. So those are the two options for storing the configuration of Failure-lambda. And it has several different failure modes that we can use. Many of them are examples that I mentioned before. For instance, adding latency to each Lambda invocation. We can set the status code. So instead of our API returning the normal 200 as it would on a successful invocation of our Lambda function, we can return any type of status code, for instance, a 404, 301, or 502, whatever type of error code we want to test to see how does my application behave in the case of error codes. We can create exceptions within the code. We can do those disk space failures that I mentioned, and we can use a deny list. That's a great experiment to do, where we are intercepting the network calls to different services, and then we're able to deny those calls. So for instance, if we have a downstream service, say a third-party API, and we can then intercept the call to that API and deny it. So our Lambda function is unable to retrieve data, for instance, from that third party. And that's a great example of how we can test if a certain failure scenario happens. What if that third party is unavailable? And to install Failure-lambda, first of course, we install it using npm, and then we just simply wrap our Lambda handler with that Failure-lambda package. So each invocation of the Lambda function will then be passed through this Failure-lambda package. So we're able to add our experiments. And the configuration, as I said, something that we store as a parameter, is basic JSON syntax. We're able to enable, disable, and set different configuration for our experiments. So back to the verification process. We now looked at what the process looks like and how we can add conditions, either by simply using CLI and console, for instance, for doing different changes, or by using tools like Failure-lambda. So let's look at some more practical examples of how we could do these experiments. So in this case, we have a simple serverless web service. We have a client calling API gateway, which invokes a Lambda function who retrieves or stores data in DynamoDB, the classic simple web service. So looking at the verification process then, we can set the objective. My objective, something that I care about in this case, is that my purchase API should respond in less than 400 milliseconds. That's important to me. So then I set the measures for that. So I'm able to measure my purchase API and of course set a threshold. So it shouldn't be above 400 milliseconds. And then I add a condition to this. In this case, I'm going to add latency to each Lambda invocation. And by adding latency, I can simulate different things. It could simulate cold starts. It could simulate different kind of code errors or runtime errors that we have within our Lambda function, or it could simulate that we have latency in any type of downstream service as well. So adding that, we're then able to verify our application. Does our application behave as we expected to, even when we have this added condition, in this case added through a chaos experiment? So either it's pass or it fails. And by doing that, we learn a lot about the application, learn about how the application behaves, and perhaps find things that we can improve with our application. So another example, still the same simple serverless web service. In this case, our objective is that I want 10 clicks per second. This is some sort of web application. So we need to have a way to measure this. We set up measures of the amounts of clicks, and we set a threshold for that. That's how we verify the application. So then we add a condition. In this case, let's inject a downstream service failure so that we, for instance, deny calls to a downstream service. In this case, DynamoDB, but it could once again be any type of service. To be able to see how does our application behave and how does that affect our objective. Does users stop clicking if a certain part of the application doesn't work as it's intended to? Well, once again, we're then, based on that, able to verify the application. Does it pass verification or does it fail? So those are two examples of how we can do this verification of our application by adding conditions. So question then is, so where should we do this verification? Well, you don't have to do this in production, of course. we want to do it as close to production as possible, because that will give us the more correct data in regards to verification. We have this other traffic, we have users using the system and so on. But you can do this simply in test environments, dev environments, and so on. And the more production-like, the better. But to verify certain behavior, you can do it in any type of environment. And that could be a way to then proceed in your deployment strategy and so on, to verify first, then move on to the next stage. So let me show you an example of how we can do these verifications then. We've looked at the process and I've shown you a few examples of how we can do it. So let me do an example so that we can look at that. So what we're going to do is look at exactly how we can add conditions. And we're going to do that by using a simple demo site that I've created, the serverless chaos demo site. And this uses Failure-lambda package, and we're then able to add conditions to it. The architecture is similar to the ones we've seen before. It's just that we have 3 different Lambda functions, so we can add conditions to each of these Lambda functions to show the difference, for instance. So we have that architecture. Let's then create a verification for that. So in this case, let's add 100 to 400 milliseconds latency to each invocation for the first Lambda function. On the second one, let's return an error code instead of returning the normal 200 response. And for the third one, let's intercept and deny connections to DynamoDB. And these are all conditions that could happen in our application and ones that we want to test to see how does our application behave. So let's switch around. Here we go. So this is the serverless chaos demo site. It's just loading. Let's see. All right. So shortly, all 3 functions are working, and the functionality is simple. Each of the 3 Lambda functions, they are invoked every 5 seconds by the client through API gateway. And what they're doing is that they're retrieving a random item from DynamoDB. That random item is returned to the client, and it contains a URL to a new image. So looking at the site right now, every 5 seconds, it's loading a new image. So what we want to do then is to add our conditions to this. So let's start first by just looking at the Lambda function. I want to show you exactly how it looks. So the package is already installed, but just to give you a quick glimpse of how that looks. So this is the function code. So I've installed the package. I have that there, Failure-lambda. And then my Lambda handler simply wrapped with Failure-lambda, so that everything that happens within that handler is something that we can then subject to these errors for each call. So as I've mentioned as well, the configuration is done through a parameter. I have the parameters in parameter store in this case. So let's start with Failure-lambda parameter 1 then. There we go. All right, so for failure parameter number 1, it is right now disabled. I've set the failure mode to latency because that was the first condition we were supposed to add. And I've set it to a minimum latency of 100 milliseconds and a maximum latency of 400 milliseconds. So for each invocation, it will add something in between those values. So let's enable it by simply changing the JSON code. There we go. And switching back, we should now see that function 1, it's still working. But if you look at the invocation times for each, function 1 has a longer invocation time for each invocation. The other ones are around 200, 300 milliseconds normally, but function 1 has added 100 to 400 milliseconds. And in this case, well, Possibly, I would say that my application still works, so it is verified, the behavior of the system. If we added even more latency to it, perhaps we would get a different result. So that could be a second condition to test. But in this case, it still works. My users would probably still be happy, even though it is adding a bit of latency, so it is a bit slower for each invocation. But let's say that that one is verified and it passed verification. So let's look at the second one then. In this case, it is also disabled for now. And the condition was to add an error code to some of the invocations. So I've set the failure mode to status code. And I'm going to return a 404. So instead of returning a 200 response, my client will receive a 404 instead from the API. And let's enable that. But as the condition said as well, it should be on some of the invocations, not all, which is probably the way that a faulty application or service would act. Let's say that it is having issues with throttling or something like that. Perhaps it will throw errors on some invocations, but not on all. So we can then change the rate of this failure injection. Let's set it to 0.5. 1 means that it's injecting failure to all invocations. 0.5 means that we'll add it to about half of the invocations. So set it to true, rate 0.5, save, switch back to the site. All right, I wasn't quick enough. Function 2 did show a 404 on the first invocation after I enabled it. Now it's 200, then it's a 404 again, back and forth on some invocations. And in this case then, well, it is working every now and then, but it doesn't work all the time. So this would probably not pass verification in this case. This is a very basic example of it, but in our application, what we would normally do perhaps then is to find a way, how would we solve these issues if they happen? Well, we could, for instance, add some sort of graceful degradation fallback, where instead of returning an error and not loading an image, we could, for instance, add a cached response, the last successful response, or have a fallback image, one that we use when there are issues, so that the users wouldn't notice that there is an issue, instead get a response, perhaps not the one that is straight from the database in that case. All right, so function 2, well, it failed verification, let's say that. Now on to function number 3 then. And this one is also disabled. And in this case, we were going to block network calls to DynamoDB. So I've set the failure mode to deny list. That means that we're intercepting network connections and able to block them. And in this case, I have a deny list that consists of calls to S3 and DynamoDB. And this could be any type of network call. In this case, it is to DynamoDB in all regions, for instance, but we could then add it to specific regions, or if it is a third party, we'd add that API network call, for instance, and able to block that. So let's edit and simply enable that. Nothing else to change. Let's save it and switch back. All right, so function number 3 is now throwing an error because the Lambda function is unable to call or at least reach DynamoDB. So it doesn't get a response back. And in this case, our application throws an error. The user isn't getting a new image. So once again, we've added this condition to see how does the application behave when we're unable to reach a certain service. Well, in this case, the application stops working. Function number 3 isn't working at all. So once again, room for improvement in the application. We would be able to, for instance, add a circuit breaker to the Lambda call. If we, for function 2, would perhaps handle that error on the client side. For function 3, that's probably something that we would handle in the Lambda function code, for instance, to be able to then have a fallback or a graceful degradation of some sort, so that the users aren't subjected to the error. So once again, we've found something that we can improve in our application. That's mainly the goal: learn new things about the application or gain confidence in that it works, even though we throw these adverse conditions to the application. So 3 examples. Right. So when we started the presentation, or if you're looking at the title, it said that this is continuous verification for serverless applications. So let's then look at how can we make this verification continuous. And this is an evolution that we're seeing from CI first, continuous integration. It allowed us to limit the number of bugs that we create by merging code faster, and the bugs, they become more apparent. So they don't geometrically lead to a larger number of bugs. So we can create features faster. And then when we can create features and software faster, that evolved into continuous delivery, CD. So we can then get our code into production faster and roll forward faster. So the next step from that is to do this verification that we looked at, but to do it in a continuous way. So that's continuous verification, or CV. So we have the same simple web service, serverless simple web service with API gateway, Lambda, and DynamoDB. And in front of that, a very simple example of how we can add our CI/CD. We have code commit, code pipeline, and code deploy to be able to deploy our application. So let's look at that example then. We have that application in place, and we now want to do this verification. So the objective in this case is one we're familiar with. My purchase API should respond in less than 400 milliseconds. So we add the measure, we have metrics and alarms in place, and then we want to add our condition to this to test and verify our application. In this case, we want to add latency, 100 to 200 milliseconds latency injection to the function. And a way to do this continuously then, well, it is to do it with the help of our deployment. So we simply enable that experiment while we do the deployment. And the experiment has this bake time, as with most deployments, where we're then watching for alarms to see if we should roll back the deployment. And the same goes here. We can then wait for the experiment to be verified, pass or fail verification. If it passes, that's great. We can then disable the experiment. If it fails, we can also disable the experiment, but we can roll back as well. So in this case, let's say that it passes. Well, great. Then we're disabling the experiment. And as you saw using Failure-lambda, for instance, that is simply just changing from true to false to disable it. And that is something that we could easily do with the help of our CI/CD to change that parameter. Another example is we have the same application and the same CI/CD. We use the same objective to make it easy. We have the measures, we have alarms in place and our threshold, and then the condition where we want to add 100 to 200 milliseconds of latency to each invocation. Well, we can then do that with the help of canary deploys, because with the previous example, that means that all invocations will be subjected to that added failure. But if we want to have a smaller scope, a smaller blast radius, we can do it with the help of canary deploys. So we do a canary deployment where the experiment is enabled. We have added that condition in simply the canary deploy. So for instance, 10% of invocations will get that added latency. And we're then able to observe that during the bake time to see how it works. And in this case, well, let's say that verification failed. So then we can just roll back that canary deployment, those 10% of invocations. So 90% of invocations wouldn't get that added latency, which means that we have a smaller blast radius and fewer would then notice if there is actually some sort of failure created with our condition. And a third one that we can use is the same application, same CI/CD, purchase API respond in less than 400 milliseconds. We have 400 milliseconds threshold, and we want to then add our condition. Well, another way of doing is to use feature flags. And feature flags is something that's, well, I'd say that it is quite common today. There are several ways of doing this depending on what you're running. For instance, using AWS services, we could use AWS app config to create feature flags. And by doing that, we're able to roll out this condition to a very specific part of our application. For instance, we can add this feature flag and enable the condition to specific users for a specific country, for instance, or we can add it to well, any type of property that we have where we're able to roll out these features. So it gives us more control over how to do that experiment. And then we're able to do the verification during the bake time. And in this case, it passes, great. Experiment disabled, we remove the condition, and then we continue the normal way we do deployment. Start rolling out more and more users using feature flags to this new version of the application. So those are 3 examples of how we can do these verifications using chaos experiments as added conditions, but to make them more continuous. Because doing them as one-offs, that's great. We usually learn a lot about it or through it, but having it as part of our pipelines means that we're able to do it with less effort, and we can do it even more automated as well. So this is something to aim for, definitely. So let me show you an example of how we can do that as well. A continuous verification demo. So this is a similar site to the other one. I'm pretty good at naming these demos. So this one is called Serverless Chaos Demo Canary site, which gives away which type of deployment we're going to do. But it is simply one website, so it's just going to be one user. But to show it as an example, it consists of user 1 through 12. So we can then roll out this as a canary, enable the condition to a smaller part of our Lambda invocations. Yeah, the application is known by now. So we want to have this objective. This is something that's important. Users should frequently get new images. Quite easy objective in this case. So let's say that the measure is 10 images loaded per minute. So I need to be able to measure that in our application, of course, and then set up alarms for this if we're below that measure. And we add a condition through our deployment. And in this case, we're gonna return error codes on invocations. So we're gonna use that status code failure mode as we used before. Add that as a canary deploy. So it will be for a smaller amount of invocations. And then we're able to verify them, pass and fail. So we could do this through a pipeline, which isn't that fun to watch. So I'm going to do it manually for now, but still do it as a canary deploy so you're able to see how it works. So let's move to the demo. All right, so open the site first. See that start loading. Should be fine soon. All right, there we go. So now it's starting to work. It's loading images on users 1 through 12 and giving 200 response. That's great. So the way or one way we could do this is by using whatever framework we're using for our deployment. So I'm gonna open VS Code, zoom in quite a bit. Hopefully you're able to see this. So this is the deployment for this application, the backend for the application, and it is deployed using the serverless framework. But we could use SAM, we could use CDK or whatever type of framework or tool you're using to deploy your applications. So as I said, I'm doing this manually now, but this should of course be automated with the help of our pipeline. So what I can easily do then with the help of a canary deploy is to switch my parameter. So I have two parameters. I have one that is disabled, and then which is then set to is enabled false. And then I have one that is enabled, where is enabled is set to true. I've set the failure mode to status code, and I've set the status code to a 502, meaning that it will return a 502 response back to the client. So then with the help of a deployment setting, in this case, canary 10% over 5 minutes, meaning that it will deploy the new version to 10% of invocations, and after 5 minutes, it will then deploy to the rest. I could then connect this to my CloudWatch alarms and watch this deployment. If it fails or it starts alerting, we could then roll back that deployment. So changing it to the enabled one, saving, and then I'm going to deploy this to Dublin. And what happens in the background now is that the serverless framework takes care of that canary deployment for me with the help of code deploy. So let's look at it as the last step of our CI/CD pipeline, what's happening now. So it's using CloudFormation. So we are going to have to give it a few seconds before the stack starts updating and then kicks off code deploy. So bear with me. There we go, code deploy. So let's see. Usually takes a few seconds. That was pretty quick. So a new deployment has started. And it has done the first step, the pre-deployment validation. It has now started traffic shifting. So 10% of Lambda invocations will now get that new version where the condition is added. Our chaos experiment is enabled. So
Gunnar, can I ask you a question?
Oh yeah.
While we're waiting for this. Phil asked a minute ago, what is the difference between parameter store and app config? And I guess, and when you would choose to use one versus the other?
Yeah, well, parameter store is basic storage for parameters of any kind. So it is an easy option for storing parameters that you can then load from different applications or different services. App config is a service that is specifically for deployment of configuration. So good practice is to separate configuration from your application. A lot of users do this through storing it in parameter store, in S3, for instance. But app config has additional benefits. For instance, that you're able to verify that your configuration is correct, the syntax is correct. You're also able to do deployment of your configuration. So for instance, canary deployments, as I'm doing right now, we can do that, but for configuration. So we can roll out configuration linearly or a gradual deployment of it to smaller parts of application invocations, for instance. And it also has the same thing that I've talked about here. You can set up alarms to monitor your application and then roll back based on that. So app config is a great way of doing rollouts of configurations. And that's why we have support for it in Failure-lambda. So you're able to do rollout of your failure configuration in a secure way, and then rolling back if it doesn't work as intended.
Cool. Well, that's awesome. Thank you for the explanation.
Yes. So what has happened now is that we are, it has deployed to 10%. So 10% of invocations now get the experiment or the failure injected to it. So looking at this, we can see that now user 4, 8, and 10 is getting the error. Now user 1 and 2, for instance. So this shows how canary deploys work with AWS Lambda. Since it is stateless, we don't have control over what users will get that failure injected. Instead, it is about 10% of invocations, but it could affect any of the users. But this, at least it works. We're able to deploy or roll out our chaos experiment with the help of our deployment pipeline. I did it manually now, but that could easily be part of what you're doing within your pipeline, your deployment strategy. And now with our metrics in place, we could then monitor this deployment to see how does this work. Well, it is throwing an error here, so it probably would then set off those alerts. And based on that, we could roll back. And that will tell us, well, we need to improve something within our application, because when we add this condition, the application doesn't work as intended. So it was a good question with app config there, because that leads me to mainly my last point, which is that we can use app config to do this as well. By using app config, we're able to roll out the failure configuration for our Failure-lambda package and do it as in the same way. We can do a safe deployment of it, of simply the configuration, and we can then monitor that and roll back as needed, the same way as I just did with the serverless framework. So to wrap up then, some just key learnings from this. Verification. Well, it tells us why it's important to explore a set of conditions. And the conditions, they are these different events that can happen, these failures that we can have within our application. And doing this, it is really not about breaking things. Even though we inject failure, we block network connections, we add latency, it's not about breaking the application. It's about learning and building confidence. Best case scenario, when we add a condition, nothing breaks. The application works as intended. That's what we're aiming for. But it is quite common that we do it and we learn something. Then we use that knowledge, the learnings that we gain, and then improve our application. We want happy users. That's the most important part with what we're doing. And it is really easy to get started doing this. Don't look at the continuous part as the way to start. Look at doing this as one-offs. So verify different parts of your application. And by verifying how a separate service within your application, for instance, works, you're able to have confidence in that. And by doing that over and over again, you learn new things, you're improving your application, and then over time, you're able to perhaps start looking at it in a more continuous way. So I want to leave us with this once again, what the reliability pillar of the AWS well-architected framework says. Testing to ensure that you can meet your availability goals is the only way that you can have confidence that you will meet those goals. So a few links, we can probably post those in Slack as well, if you want to look more at the reliability pillar or try out both the demo apps or the different packages or tools that we can use. And with that, well, we've looked at how to verify the behavior of our serverless applications through verification and by adding conditions. So we can learn and build confidence. My name is Gunnar Grosch, and I want to thank you all for joining.